Hello, and welcome back. Today, I am going to demonstrate the Proteus design and simulation of a transformerless Arduino-based self-switching power circuit. The circuit is composed of 4 sections: the transformerless power section, the switching section, the programming section, and the load section. Here is the circuit diagram, which has already been designed and connected. In the transformerless power section, I used 3 voltage-dropping capacitors to boost the current capacity of the circuit, enabling it to support the Arduino board or 8MEGA328 microcontroller, the load, and all other components. The more voltage-dropping capacitors used, the greater the current carrying capacity of the circuit. However, this also increases the voltage drop, necessitating adjustments to circuit components. Here's the AC source. These are the voltage-dropping capacitors, connected in parallel with a 1 megaohm resistor. These diodes are arranged to convert AC to DC. Here is the electrolytic capacitor for ripple filtration, a current-limiting resistor, and a 16-volt Zener diode to reduce the voltage to 16 volts, which can be adjusted to achieve the required output voltage. This is an indicator in series with a current-limiting resistor that shows whether the circuit is on or off. This is a 1 amp fuse, which is needed in the physical implementation of the circuit. In the switching section, we have the Arduino Uno board. Below it, there is a 5-volt relay and a transistor, which make up the switching section. In the load section, we have an LM317 adjustable voltage regulator configured to provide the actual output voltage needed for our load. With the help of these resistors, the circuit configuration is achieved. Here, I used a DC motor as the load. This voltmeter monitors the load voltage. All these components can be picked from the Proteus library. By double-clicking on the device selector, you can choose any components you need and adjust their values as required. Before we move to the programming codes, let me explain the working principle. As we can see, there is one push button and a switch. The push button turns on the power circuit, while the switch connects the load to the power circuit. For the entire circuit to remain on, the load switch must be turned on immediately after pressing the power push button. Without the load drawing current, the entire circuit will turn off after the push button is pressed. To keep the circuit on, the load must draw current up to the set threshold in the programming codes. If the push button is pressed and the load circuit is connected by turning the switch immediately, the whole power circuit will remain on. Once the load circuit is turned off, the power circuit will turn off as well. I connected this switch here because the adjustable voltage regulation circuit draws current up to the set current threshold due to these resistors in its configuration. This is the point where I tapped the current signal for comparison in the microcontroller. I connected this to the Arduino Uno board using the default terminal connection. The terminals with the same label are connected together, as is the output pin to the transistor. This point is connected to A0 of the analog pins of the Arduino Uno board, while pin 2 is the output pin connected to the base terminal of the transistor. You can see how they are all connected. Next, we move to the programming section. Here are the programming codes. Define the input and output pins, the analog pin A0 or any other analog pin you desire as the input pin, and pin 2 or any other digital pin you desire as the output pin. The threshold current is set to be 100 milliamps. Adjust this value according to your requirements. Inside the loop, we have a condition to check if the input analog value is less than the current threshold. If so, the relay pin should be low, off. Otherwise, it should be high, on, energizing the relay and keeping the whole circuit on steadily. Now, let's run the simulation to see how it works. Once you press the push button and immediately turn on the switch, the load draws current. By sensing and comparing the input signal with the set signal, the Arduino Uno board communicates with the relay circuit to either activate or de-energize it. If the input signal is equal to or greater than the threshold current, the relay will be energized, keeping the entire circuit on until the load is disconnected by turning off the switch or adjusting the potentiometer to lower the output current below the threshold. If the switch is disconnected, the relay de-energizes and the power circuit shuts off. It might seem like the power circuit takes time to shut off due to the stored charges in the capacitor, but in practice, it doesn't take that long. Thank you for watching. I hope you enjoyed it. Please subscribe to my channel for more updates.